Section 11.6 has the last two tests. So we're going to learn about a thing called the ratio test and another one called the nth root test. And connected to those, we're going to talk a little bit about the different kinds of convergence. So up to this point, we've just said something converges, but actually there are two flavors of convergence. One is a much stronger version than the other. So let me start with the ratio test. So as always, what we're looking at is a series. Let's do a very generic one. That one, right? Could be any series in the universe. And if you want to use the ratio test, what it says is that you have to find the limit as n tends to infinity of the absolute value of an plus 1 divided by an. And we'll assume that this limit is equal to something called L. Right, so it could be equal to 2, it could be equal to 0, could be equal to infinity, right? So it's going to be somewhere in that general range. Now, what the ratio test says, it says the following. If L is a number less than 0, the series converges. In fact, we stick another word in front of it. We call it absolutely converges, or converges absolutely. It's another way of saying it. That is all. It's just a version of convergence, right? It's just a really good one. Now, if the limit of this ratio is greater, and I'm putting 0. I told you I was tired. Less than 1, right? If it's greater than 1, then the series diverges. We do not have different versions of diverges. You just diverge. And unfortunately, if this thing is equal to 1, then we have an inconclusive test, which essentially means we do not know if the original converges or diverges, right? We just don't know. So at this point in time, we're going to do some questions using the ratio test. And if it ends up being a limit that's less than 1, we're going to say that you converge, but we're actually going to say better than that. We're going to say you absolutely converge. If it's greater than 1, we're going to say you diverge. And if it's equal to 1, then it is inconclusive. Now, all the questions in this section, there's what, 19 of them roughly, they are all going to use one of these two tests. So you don't need to decide or pick them. But the usual kind of shape that these particular series have that makes the ratio test good, any kind of series that's got factorial in it, you know, like n factorial somewhere or n plus 1 factorial, that kind of thing, a ratio test is a really good thing to use. Anything that's got combinations of 7 to the n and powers of n, like 7 to the n over n cubed, right? Anything that looks like that, that's also a good series for doing the ratio test on. So let's pick one. I'll keep that here. So imagine that I wanted to find out whether this thing converges or not, and it's going to be 7 to the n over n squared. Now the guy that we are calling e to the n is this fella. We also need to know another guy called en to the en plus 1, Right. Now, this fella here, you get him from here. Can you imagine all you're going to do is replace this n and that n and any other n with an n plus 1. So it's 7 to the n plus 1 over n plus 1 squared. Does that seem reasonable? That seems pretty obvious. That's how you do it. Right. So we now are going to find the limit as n tends to infinity of an plus 1 over n. So this is going to be a little bit ugly algebra, but essentially on the top we put this guy, and on the bottom we put an, which is this guy. Now if you are dealing with a fraction where the numerator and the denominator are just one of them is a fraction, you know that we're not going to leave it that way, right? We're going to try and arrange it algebraically to be something easier and simpler to deal with. So that's what I'm going to do now. It's going to be the limit as n tends to infinity of the guy on the top divided by the guy on the bottom. And that's really just an intermediary stage, because the real stage that I was trying to get to is the guy on the top multiplied by the reciprocal. You remember that rule that when you divide by a fraction, you multiply by its reciprocal, right? And very often that line never gets written. After a while, you just do that guy on top times the reciprocal of this guy, right? That guy on top times the reciprocal. Now, at this point, you do not start jumping in and trying to find the limit as n tends to infinity. Always think about making your life simpler. Simplify, cancel. See that 7 to the n plus 1, won't it cancel with that 7 to the n? And what will get left over?
Thinking of 7.
Yeah, and won't it be in the top? Would you agree? 7 to the n plus 1, 7 to the n, cancel, 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 but there's 1 left over on the top. Now, if that said, oh, I know, n plus 4, wouldn't there be a 7 to the power of 4 on the top, right? So there's a 7 on the top. And I'm going to leave the n squared, and I'm taking the whole thing on the bottom, and I'm going to distribute it. So we are looking, I know that looks weird, I should have written it closer, but isn't the top 7n squared and the bottom's a quadratic? You agree? 7n squared and the top is a quadratic. Since I know everything here is positive, I don't really need the absolute values, right? These guys. Secondly, if you forget about them, right, they're not there anymore. How do you think I could find this limit? What methods could we use to find the limit of 7n squared over n squared plus 2n plus 1?
I think L'Hospital would be the quickest.
Yeah, L'Hopital will work. That's true. None wrong with L'Hopital. It's a good answer. I would do it. What would be the other choice if I didn't want to do L'Hopital? What else could we do to the top and bottom to simplify it first, and then we could get the answer?
Can divide by n squared.
Yeah, you could do that technique as well. Now, I think both of them, in this question, both of them are totally okay. Can we pretend for a minute that that was n to the 10 and this was n to the 10? If you try to do L'Hopital, couldn't you end up having to do it an awful lot of times? But I mean, it's not impossible to do it. And I think in this case, both versions, you know, both methods are totally okay. Which one do you want me to do? L'Hopital or divide top and bottom by n squareds? Which one do you want me to do? Got a preference?
L'Hopital.
Okay, then put a little L to tell everybody that that's what you're doing. Differentiate 7n squared, you get 14n. Differentiate the bottom, you get 2n plus 2. Well, it's not unusual. If I put in infinity right now, it's still indeterminate form, but we know that you can repeat L'Hopital as many times as you need. So I will do it one more time. And if you differentiate 14n, you get 14. And if you differentiate 2n plus 2, you get 2. And so the answer is 7. So far, so good. Now, according to the ratio test, you find the limit. In this case, it's 7. If it was less than 1, we have an absolutely convergent series. If it's greater than 1, which this is, agreed? Greater than 1. So isn't our conclusion that this series diverges? By the ratio test. How does that look? You comfortable with the conclusion that you get from that limit? Now, if I did another different question and the answer was a half, right? That could happen. Suppose the limit was a half, different question. Wouldn't the conclusion be it's absolutely convergent? If the next time I do it and the limit's 8, diverges. The next time I do it is 0.1, converges, right? If I ever get equal to 1, I'm going to be really annoyed because that means I don't know the answer and I'll have to find one of the other 10 tests and try that one instead. Maybe I don't know, an integral test or something. Any questions about that method? We're good?
Yeah, with all these tests, what's a good way to organize them? How you know which test to use?
Once we finish this, there's a section that comes right after this one where it's called strategies for testing or something. And
Okay.
we'll talk about it right now. But in general, if you ever see powers like this, exponents and powers, ratio test is a good test. If you see factorials, which is what my next question is going to include, anywhere, top or bottom, right? Don't matter. If you see n factorial, right, that kind of thing, then the ratio test is a good candidate, right? There are some series where more than one test will work, right? So you might be able to do an integral test and a limit comparison test, right? That's great, because now you've got 2 ways to get the same right answer. Although one of them might take you longer, you could still do it. But we'll talk about that in more detail in the next section, right? Where basically we give you a whole mixture of ones and we'll say, okay, look at this guy. Can you see it's got this kind of feature? That tends to be this test. For instance, right now, if it has a factorial on it, it tends to be the ratio test. If it has a combination of powers like this and that, like these 2 guys here, it tends to be a ratio test. Okay, now let's do a factorial one. I'm going hunting for one. How hard can a factorial be? Okay, this is question 8. And they've decided to use k instead of n, which is totally fine. There's your guy. Now, instead of n, I'll call it ak. ak is this guy. ak plus 1.
Is the K just like the N? Is it just like a placeholder?
Yeah, it's exactly that. You could have called it MPR and it wouldn't change a darn thing.
Okay.
They like n, and most of them are written as n. Occasionally they throw in a k. I don't think I've seen any other letter in any of the series. Is k and n about the only 2 they've ever sprung on you?
I would say sometimes you see Z sometimes.
Okay. So there's another letter that they might choose. It's a placeholder. You could turn everything into n's and you get the same conclusion when you're finished. So we're going to do the limit as n, oops, there I go, as k tends to infinity of ak plus 1 over k. That's going to be the limit as k tends to infinity of this guy divided by this guy. Now, both of these things are positive. If they're positive, you can forget about the absolute value, right? It doesn't, it's not necessary, because the absolute value is going to give you a positive answer as well. Now, in this question, I'm going to skip the division line. I'm going to write this as the top guy times the reciprocal of the other guy. And you see, well, I guess I'll put curly brackets, but you see, I don't need the absolute value.
Professor, I have a quick question.
Mm-hmm.
So in the top part of that fraction, the 4k plus 1, is it being multiplied by a 1 there? Oh, it's that.
No, it's a
factorial.
factorial. Yeah,
Okay.
I lost my dot. Now, at this point here in the process, you're thinking, what cancels with what, right? You're trying to simplify, typically by cancelling. Is there anything you can see? Because I can see a couple of choices. Anything that you can see that cancels with someone else?
It looks like if you cross out the k factorial and the numerator, right?
Right.
Then
What would be
you can-
left if you did that?
just k plus 1 on the bottom.
Correct. You all comfortable with that k plus 1 in the bottom?
Yeah.
You know, a k factorial. If you wanted to see what's going on here, there's the k factorial. Here is the k plus 1 factorial that we're going to cancel it with. K factorial is 1 times 2 times 3. You finish at k. K plus 1 factorial looks almost the same, except you finish at k plus 1. And the guy just before k plus 1 would be called k. And now you can see everybody cancels, and it's 1 over k plus 1. So that's why you got what you just said. Would you also agree that there's a very easy cancel, a 4 for a 4? So what's left is that. Now, this one, I don't need to do anything clever. I can do brute force. So the limit to this ratio is 0. And 0 is definitely less than 1. So that means the series sigma k equals 1 to infinity 4 over k factorial converges. Absolutely. I'm writing it the other way around. Or absolutely convergent is another way to say it. It converges, it's just a better version of converge. How are we doing? You see this process has kind of got like, you know, my usual turning a handle. You do this, you do this, you do this. You got a little limit at the end. It's going to be a number, right? It's going to be 0, 42, a half, could be infinity. By the way, if you do get infinity, isn't infinity definitely bigger than 1, so the series diverges? So infinity is not a, oh, I don't know what to do. If the limit to this ratio is infinite, it means the series diverges. It's like, heck yeah, it diverges, right? Really badly diverges, if you can say things like that. Now, the next one I'm going to do has a bit
And
of everything. Yes.
Professor, real quick, if we had a question like that on the final, could we just say, like if we get it to the part where it's comparing infinity to 1, can we just write like infinity is greater than 1, so it clearly diverges?
You would say that, and then you would say something like series diverges, and then you would do.
Okay,
You-
and we have
You're having to tell people what test you're doing. I know it's kind of obvious when every question is that test, but in the future it might not be so obvious what test you're using. So you
Okay.
need to. I just abbreviate it, you know, because I think I've done it so every test has its own unique abbreviation. Right. So if you see CT, it means comparison test. But if you see LCT, doesn't that mean limit comparison test?
Yeah.
Right. So, yeah. Yeah, you would just basically, you get the answer infinity greater than 1. Series diverges by the ratio test. Are we good? Right. The next one I'm going to pick is actually a wind back to question 7. And I chose this one because it's got pretty much everything in it. It's missing one piece, but that's fine. The next one I do is going to have everything in it. And you get a 9 to the n. On the bottom, you've got a 7 to the n, and you've got an n cubed. Would you agree that's one pretty ugly looking series? But it's got the features that make it a ratio test. Do you see a number to the power of n and an n cubed, n squared kind of thing? Do you see that? That's almost always going to be a ratio test when you see that combination. So far, so good? Right, ratio test it is. The guy that's called an is -1 to the n minus 1, 9 to the n over 7 to the n, n cubed. In other words, this guy. The guy that's going to be a, make that an n, an plus 1, that n gets replaced by n plus 1. So n plus 1 take away n gets me -1 to the n. That guy becomes 9 to the n plus 1. That guy becomes 7 to the n plus 1. And that guy there becomes n plus 1 cubed. Are you happy about all the 4 pieces and what they turned into when the n gets replaced by an n plus 1? That -1 might be the weirdest looking one, but think about that. It's n plus 1, take away 1, and that's why you get n. So let's do the ratio test. The limit as n tends to infinity of an plus 1 over an. It's going to be the limit as n tends to infinity of and I just put the wrong guy in there, turn it in space. This guy goes there. So now this guy goes downstairs. So we have fraction, fraction, which is pretty common. So it's now going to be the limit as n tends to infinity. Right, let's do a couple of things here. This absolute value, if you remember what that does, it just makes the answer positive. So do you see this -1 to the n guy and this -1 to the n minus 1 guy? See these two -1 guys? See if you stick an absolute value around them, don't they basically just turn into the number 1, which means they don't matter, right? Because 1 times 9 to the n gets you 9 to the n. For that reason, I am removing the absolute values and just turning this guy into that slightly nicer looking format. Because the absolute value of -1 to the n is 1, and 1 times 9 to the n plus 1 is 9 to the n plus 1. So if you're doing a ratio test and there's -1s to the powers everywhere, can you basically like rub them out and it doesn't matter, doesn't affect anything, because they become 1. Now you turn the other guy upside down, and we're here. Okay, it's time for a battle. There's going to be a lot of casualties. Okay, pick somebody in the top that can kill off party somebody in the bottom. Any volunteers? Somebody in the top that kills somebody in the bottom.
At 9n plus 1 could kill the 9n.
And won't it leave, what, a single 9 on the top?
Yep.
Okay. Anything else to cancel? There's
Same
one more
exact
thing.
thing. The sevens are the same deal. Sevens left in the denominator.
Agreed. So what we're looking at right now is the limit as n tends to infinity, 9n cubed over n plus 1 cubed. Are we comfortable with the bits that are left over? Oops, almost made a mistake there. We comfortable with the bits that are left over? Right, now there are two approaches to this one. Approach number one, couldn't I FOIL that darn thing out and get a cubic? It'd be 7n cubed and a whole load of other stuff. And if I did that, I could then divide the top and bottom by n cubed and I would get the answer. So that's strategy number one. I don't want to do that because it's too long. I mean, it's doable, but I think it's too long. So I am just going to bite the bullet and do L'Hopital. Well, that's going to get me 27 n squared. If you differentiate this guy, you are going to get multiply by the power and reduce it by 1. It's still ugly, right? But we can deal with it. I'll do L'Hopital again. And we get 54n on the top and 42 n plus 1s on the bottom. It's getting nicer. Right, power rule, 54n, power rule. Technically it's a chain rule, but times 1 doesn't really do anything useful. Now, if I differentiate the top one more time, using L'Hopital, I'll get 54. And that bottom guy, if I think of him as 42n plus 42, it makes differentiation easier. I get 42. And there's our answer. That should cancel down a bit. What can you get? You should be able to get at least a 9, 3. 3 then. How about 3? That gets me 118. 3 into this guy gets me 114. Okay, I can do 2. That's 9, 7. Okay, there's my answer. I believe it's 9/7. Okay, conclusion time. The limit of this ratio is 9/7. What's the conclusion? The limit is 9/7. Which is our correct conclusion?
Diverges.
Because it's bigger than 1. So the answer, you're right, it diverges by the ratio test. At least this test doesn't require a lot of variation. Would you agree? It's kind of the same old stuff, just with different expressions, right? Turn me upside down, multiply, cancel everything that you can. Once you've got everything cancelled, figure out what that limit is. You know, divide top and bottom by n cubed or n squared or repeated L'Hopital.
So couldn't you just say simply that the 9 and n to the cube, you know, if you do your FOIL method on n plus 1 to the cube, you're gonna have an n cube. So you could just divide everything by n cubed. The only thing's gonna be left over is 9/7.
Oh, let's try
So
that.
why go through all that?
Yeah, I like that. Yeah,
Hmm.
let's do that. You got
I
9.
was thinking the same thing. Like if you
Right.
were to FOIL that out, could you just make a note saying like, I already know this is the highest end value, so just skip to that and do it.
It's equivalent to what John's saying, but the way I heard John describe it, I like. Right, divide that guy by n cubed. If you take n plus 1 cubed and you divide it by n cubed, do you know you can bring the n inside and you're basically doing that guy. Right. And now if you brute force it, you get 9/7 and 1 plus nothing cubed is still 1, so you get the 9/7. Now Eric's idea of you could say something along the lines of that's n cubed which it is. That's the biggest power. That would make sense to me. I think you just have to be really precise about what your assumptions are.
Okay.
And you would get 9 sevens, so I know it works. Is that kind of what you were thinking, John?
I think I was thinking more along the lines of Eric, knowing that whenever I do the FOIL method,
Uh-huh.
my highest power is going to be n cubed, which is automatically when you divide by n cubed, it's going to be 1. The
And
rest
the
of
other
the,
terms aren't.
the rest of the terms are going to go to infinity or 0, excuse me.
Yeah, because I was thinking,
yeah.
could you just cut them out, even though I know it's not like mathematically proving it.
Well,
It's
you
just
could.
common knowledge that it is.
Well, you could. It's not that difficult. That's what it would be when you're finished. It's just one of those things that you memorize, you know, like n plus 1 squared. Because in the ratio test, that's essentially what it would be if you did it in full. So as long as you were clear about it was n cubed and the other terms were less than n cubed, and so when you divide, you're going to get 1 plus some terms, you'd have to kind of be just, it's very precise to get that out. I mean, this trick would work. Doing that to it would work. And technically, what you said would work, but you have to be really careful about how you say it.
Okay.
Let's find some weird, well, question?
It's just like making a statement against a lawyer, you know, really careful with your words.
Exactly. I want you to think like we're proving things here, right? We're proving things here in the way that you would try in a court of law to prove something, where the opponent is going to jump on even a slight inconsistency or vagueness in your argument, right?
All right.
That's a good analogy. I'm trying to find something. Well, there's a lot of weird ones going on here, so let's pick just another really horrible one, then we'll do specifically weird ones. So this one I'm just making up. Let me do that again, put the line too high. There. Right. That one has got pretty much everything that you could possibly get in one question. Most questions only have like 2 or 3 of those pieces, right? They have maybe that guy in the bottom and maybe that 2 to the n and this fella, or maybe the 2n factorial and that guy, right? They don't necessarily have all of them. But I'm figuring that if I can do the worst case scenario, all the other ones are going to be a lot easier to deal with. So AN is the untouched version. And by the way, that 7 to the 2n plus 1 is going to be an issue. Now, if you want to do an plus 1, take each piece and replace the n by n plus 1. So that's that guy. 2 to the n, 2 to the n plus 1. N factorial, n plus 1 factorial. So far, so good. N squared, n plus 1 squared. That's the one that's going to catch us. 7 to the 2n plus 1. You are going to replace only that n there. Only that n there with n plus 1. So you get 7 to the 2 lots of n plus 1, add 1. Are you comfortable with what I just did there? The n, that's this guy here, is going to get replaced by n plus 1. So it's 2 lots of n plus 1, add 1, which if you tidy it up is 7 to the 2n plus 3. Are we okay with that? That's the weird one. Okay. So we have 7 to the 2n, add 3. And then the ratio test is the limit as n tends to infinity of an plus 1 over an. All of this goes on the top. All of this goes on the bottom. And then this guy the more of these questions you do, the more you kind of compress things, and maybe you don't write this line at all. Instead, you jump right into this line. Everybody in the top. Times, oops, looked at the wrong place. There, fixed it. Times the reciprocal of this guy. So what we got? Right. All hell's going to break loose on this one. Well, let's do the easy bits. Do you know all those negative ones to the n's and n plus ones and any other thing? Don't they basically not matter because the absolute value kills it? So just don't even bother about thinking, oh, there's a minus 1 to the n left behind on the top. You stick an absolute value around that guy and it still ends up being positive 1. So it has no effect on the final result. Okay, time to start picking guys in the top and bottom that cancel. Who you got this time? Somebody in the top cancels with somebody in the bottom, and there's lots to choose from.
The chewing.
Okay.
So we're left with a chewing the numerator.
Okay, agreed. Okay, pick something else. What else can cancel? Anybody?
Factorial.
Okay, and if you do that with that, would you agree there's an n plus 1 left on the top? Now, the one that you're all, not surprisingly, a bit hesitant about is that this does cancel with this guy. See these two guys here? They do cancel. If I write them separate, you've got a 7 to the 2n plus 1 on the top and a 7 to the 2n plus 3 in the bottom. Little guy, big guy, they cancel. What power of 7 is left on the bottom? What's left over when you take away that amount from this guy?
Oh, -2.
Well, yeah, but yeah,
Oh,
but
I mean, and then
yeah, I know what you meant. The
Choose.
denominators 2, yeah.
Yeah.
Does that make sense that the difference between the two is 2 and that the bottom gets it, right? It's the bigger of the two choices, which means that we now have a7 squared on the bottom. And we don't need the absolute values and stuff anymore. So I have 2, I have n plus 1, I have an n squared. On the bottom, I've got 7 squared, which is what, 49. And I have an n plus 1 squared. Things looking good. And I just noticed something. I can do a little bit more cancelling. Always good idea to cancel, even if you don't do it the first time, you catch it the second time. Can you see anything on the top that cancels with something on the bottom?
N+1.
Yeah. Which means, isn't there just going to be a single n+1 in the bottom? So we are now looking at the limit as n tends to infinity of 2 over n squared over 49 n+1. Well, I could divide the top and bottom by n or n squared, but I'm going to do L'Hopital. And so what do we get? We get the limit as n tends to infinity, power rule 4n. That's basically 49n plus 49, so you get 49 when you differentiate it. And that is infinity. So the limit here is infinity. Okay, what conclusion do we make about this series? The limit is infinity. What's our conclusion?
Diverges.
By the ratio test. Why? Because it's greater than 1. Infinity is definitely greater than 1, right? We're good? Right. Most ratio tests do not have, like, what's that, 5 pieces to it, right? Most ratio tests will have some of those pieces, maybe 2 or 3 at any given moment. So let's look at some of the weird ones. So here is a weird one. This is question 10. And it's n equals 1 to infinity. 11 to the n on top. N plus 1 and 8 to the 2n plus 1 on the bottom. Now it's got 3 pieces to it rather than 5, which is nice. An is this fella. And an plus 1 would be that guy. Okay, what will be n plus 1? What will n plus 1 turn into when we replace the n with n plus 1? It's a weird way of phrasing it, but what will this turn into when the n gets replaced by n plus 1?
N+2.
Yeah. Now this one's messier, so I'm going to do that at the side. If you are taking 8 to the 2n plus 1 and you replace the n with n plus 1, you get that guy. And then if you distribute everybody, do you see you get that 2n plus 3 thing, not unlike the other one we did? You notice that? 8 to the 2n plus 3. So let's go for it. 8 to the 2n plus 3. So the ratio test is the limit as n tends to infinity of an plus 1 over an. It's going to be equal to, well, everybody's positive, so I won't worry about the absolute values. Here is an plus 1. Multiplied by the upside down version of an. There we go. Well, you know the next step, isn't it? This guy cancels with that guy, simplify it down to the point where we can do it no more. That 11 to the n plus 1 cancel with that 11, and I get 11 left over. Just one 11. That 8 to the 2n plus 1 cancels with that 8 to the 2n plus 3, If you take that away from that, do you see you get 8 squared left on the bottom? You agree? 2n plus 1, 2n plus 3, there are going to be 2 of them left, 8 squared on the bottom. So we now are looking at the limit as n tends to infinity of 11 over n plus 1. And 8 8s is 64, n plus 2s. So far, so good. You know, I could do, well, let's do it that way. What I would probably do in this question, although there's other ways to approach it, would be just to simplify, well, maybe simplify, but to multiply out that. And at this point here, couldn't I do L'Hopital or divide the top and bottom by n? And I seem to be on a L'Hopital binge tonight. You get 11 over 64. And there's your answer. The limit is 11 over 64, which is less than 1. So that means that the series is absolutely convergent. By the ratio test. Right, so the limit of that ratio was the number 11/64 because it's less than 1, absolutely convergent. The more of these we do they begin to have a flow to them? Right, kind of you do this, you cancel, you get an answer, and at the end you do L'Hopital, divide top and bottom by n squared, whatever it takes, and you get a number. And if that number, the limit of the ratio, if that number is less than 1, absolutely convergent. If it's bigger than 1, divergent. That's it.
It seems like we could have done this test on some of the ones we had on our quiz yesterday.
You could. I took one of those questions out because accidentally I had a ratio test in it. So I just took it out and rescaled it so it was still out 100. You could, and you will find that a lot of series can have more than one method. Right, you might be able to do 2 methods. I guess if I worked hard on it, I could probably find a series where there'd be 3 different tests you could use, all of which would work. So I guess the bottom line there is not what test you use, but what one you remember that works, or which one is the least amount of work would be a really good choice, right? If you had 2 and you're pretty sure both work, you probably should pick the easier, right? The one that's easiest to do. And that's a skill that comes through experience, that's all. Are we cool with that one? Let's see what else we have. Okay. I'm going to do a question in a moment, but before I do it, I have to remind you some magic. Here are 2 ratios that you will just accept. The limit is n tends to infinity of n to the power of 1 over n, which is just another way of saying the limit is n tends to infinity of the nth root of n, right? That's just another way of saying it. The answer to this is 1. And you're just going to take my word for it, right? It is 1. And it's been proved by other people, so we know it's true. The second piece of magic I'm going to give you is this one, which I do know I have mentioned it in passing a couple of times. Does anybody remember what this, and it is a number, what does this converge to? 1 plus a over n, all raised to the power of bn. E to the power of ab. Now, those two, you will just assume that you're allowed to write them down without proof, right? Someone else figured it out for you. That's what they're equal to, right? You're willing to trust those two pieces of magic. Magic is when I tell you something's true and you have to believe me, right? So let's show you a ratio test that requires usage of at least one of these two things. Question 12. Oops. Sigma n equals 1 to infinity n factorial over n to the power of n. Okay, let's go. En is n factorial over n to the power of n. En plus 1 is n plus 1 factorial. Be really careful here. What does that bottom expression become when n gets replaced by n plus 1? What does that become when n gets replaced by n plus 1?
N plus 1 to the power of n plus 1.
Agreed. Do you agree that looks weird, but that's what it is? Does that make sense? N to the n becomes that guy. But good. Right, now, let's take this fella on the road.
Can we use the rate of growth on this one?
Well, if you did use the rate of growth, all you would know is that that has a limit of 0. But that doesn't help us tell whether it converges or not.
Okay.
Oh, are you thinking later on?
No, go ahead. I was
Okay.
thinking now because like,
Yeah, the only time that would be useful is if I did this to you. So let me show you a different version of that question where you could do the rate of growth. You wouldn't need the ratio test for this one,
okay.
because according to the rate of growth, this fella has a limit of infinity. And so wouldn't that work with the divergence test?
Okay, thanks.
Right. But the other way around, unfortunately, just because the individual terms are 0, which is what the rate of growth would tell me, it doesn't mean that the series converges. Sigma 1 over n has that property, right? 1 over n goes to 0, but the series doesn't. It still diverges. So the ratio, and that's going to become the limit as n tends to infinity of n plus 1 factorial over n plus 1 to the power of n plus 1. And let's not write the line. Let's just turn this guy upside down, right? There we are. Everybody is positive, so I don't need the absolute values, but I do need to do some cancelling, and there's not that much direct cancelling I can do. Would you agree that that n plus 1 factorial cancels out that n factorial, and that leaves me with an n plus 1 factorial on the top? Are you comfortable with that cancel? Right. So now we've got n plus 1 times n to the n and I'm trying to do something here because I'm hearing some. How can I do that? I should be able to just mute one person. Okay, Natalie, if you could mute yourself, I think it's Natalie anyway, that would be good. So where are we going? We got this guy, we got this guy, we have n plus 1 to the n plus 1. And that's what we're looking at right now. Right? That's all that seems to be left. do you notice that the n+1 here cancels one of these n+1s? Do you see that? So if I cancel this, don't I leave behind essentially just that fella? So after a kind of a second pass at all the stuff, I have this guy over this guy. Agreed? Agreed? We cool? Now, nothing that looks like this has appeared yet. That's because there's a lot more algebra still to go to get it to look like this guy. It's going to be the limit as n tends to infinity of n over n+1 to the power of n. Are you comfortable with two guys with the same power can be compressed into a single power?
Yeah, I forget it all the time, but yeah.
Okay. Now, this next one is not obvious, but I need to do it. There's a strange piece of algebra. I have taken this guy and made it into its reciprocal. And now I'm changing that to -n to make the thing balanced. Now, if you want to see why that's allowed, this is kind of the long version of that same process. Or in the future, you can just trust me that that little algebra trick is cool. So I have n over n+1 to the power of n. And what I'm going to do then is I'm going to call it n+1 over n to the -1 to the n. Now, if you stick a -1 in something, it's basically you're turning it upside down. Reciprocal. And a guy to the -1 raised to the n gets you that. And that's basically the reason why that's allowed to be done. So if you take something and you make it upside down, you've got to compensate by making that a negative power. It's a bit like squaring and square rooting. Well, here, oops, here I'm taking it, I'm turning it upside down, that's a negative power. I'm balancing it by giving the other guy the negative. Right, I'm moving over to the other guy. Now, this fella can be rewritten like that, which now becomes hey, we got one. You see how much work it took to get that guy? Right. Now, if you look at this fella, he is 1 plus something over n raised to the power of bn. Now, in this question, a is 1 and b is -1. A is 1, b is -1. So this is e to the 1 times -1, e to the -1, which is also the same thing as 1 over e. So that's what the limit of the ratio is, 1 over e. Is 1 over e bigger or less than 1? One over e, is it bigger or less than 1? E is 2.712 if you don't know. Yeah, less than. So it's absolutely convergent. By the ratio test. Are we good?
For about a day.
For about a day. You gotta just get as much practice on these as you can then, so it lasts a little bit longer. So that's pretty much the ratio test. That's, I hope, enough examples to kind of give you a kind of insight into what we're going to do. The second test, our final test, is called the nth root test, or as this book calls it, the root test. I like the nth root test for two reasons. First one is I can call it NRT, because if you have a root test and a ratio test, don't they both look like RT? And it's hard to tell the difference. So I like it for that. And the second reason I like it being called the nth root test is because it gives you a little bit more insight to exactly, the test itself. And this is what it says. For a series, any series you like, sigma n equals 1 to infinity an, we find the limit as n tends to infinity of the nth root of a to the n. Technically, there's some absolute value going on there. That's just in case there's a -1 to the n floating about, but the nth root of an. And it's going to equal something. We'll call it L. And this is familiar. If L is less than 1, then the series absolutely convergent. If L is greater than 1, then the series is divergent. And we do not want this. But if L is equal to 1, then the test is inconclusive. So it's the same basic limits, right? If this is positive, or sorry, it's always positive. But if this is less than 1, you've got absolutely convergent. If it is greater than 1, you've got divergent. And if it's equal to 1, you don't know what's going on. And so the test is inconclusive. So that's going to be our new guy. Now, let me show you the tests that are designed for the nth root test. Right? What makes them nth root tests rather than any one of the other 10 that we know about? So let me go here and yeah, okay. If you see a series with ugly fraction raised to the power of n, it's the nth root test. Ugly fraction raised to the power of 6n, 4n, n squared, 2n squared, right? Ugly fraction to a weird power, and that power has n in it, or n squared, or 2n. Then it's a ratio test, an nth root test, I should say. See this guy here with n squared in it? Nth root test. See this guy? Well, that's the end of that one. And these just go on to talk about the other stuff. So you're not going to get the same exposure that you would have got for the ratio test, because the nth root test is a like specialized market, right? It's only used for very unusual series with powers of n in it in all the weird places. So here is a version of 14. And it's going to be 2n plus 1 over, make my brackets bigger, over en minus 2 raised to the power of n. Now, this is an. So we are going to find the limit as n tends to infinity of the nth root of an. So that's going to be the limit as n tends to infinity of 2n plus 1 over 8n minus 2 to the power of n. And we are going to get the nth root of it. Now, some people are quite comfortable with the nth root. Here is an equivalent to what an nth root looks like. If you raise something to the fractional power 1 over n, it's the nth root. So for instance, won't a square root be a half power, right? And a cube root would be a third power. So either one of these two work. Let's use this one. What's going to happen when you take this fraction to the power of n and raise it to the power of 1 over n? Well, won't those two essentially cancel each other out? You know, like the square root of x squared, that kind of thing. So that means we are now left with the limit as n tends to infinity of a much, much simpler guy. You agree? Now, I could do L'Hopital on this. Why don't we divide top and bottom by n just to be different? And so the limit as n tends to infinity of 2 plus 1 over n and 8 take with 2 over n. Then I just make infinity, you know, brute force it all. 2 over 8, which is a quarter. Okay, conclusion time. The limit of the nth root test is a quarter. Conclusion.
Absolutely converges.
Yes, like we're emphatic about it. It absolutely converges. Yes. So the series is absolutely convergent by the nth root test. Now you don't get to see many series that look as weird as this, right? It's not a very typical series, right? That's why it's a very niche market. But there's one more I want to show you because it uses the magic guy, right? Well, actually, let's do two. Let's do this one first, and then I'll do the magic guy. Right, let's take that guy. We good? Right. This is n, or en, I should say. So we're going to do the limit as n tends to infinity of the nth root of n. In this case, it's going to be the limit as n tends to infinity of the nth root, technically the absolute value guy. And what that absolute value guy does is it kills this negative. It means we don't need to worry about the negative anymore. And all we're looking at is 3n over n plus 1, right, to the 6n. Now, if I leave it as an nth root, would you agree that the nth root of this guy do cancel, at least partly? What will happen to the 3n over n plus 1 when you take the nth root of the 6th power? How will these two interact? The nth root of the power 6n.
They'll cancel each other.
And what will you be
They're
left
just-
with?
they're
So again,
just power. The ends will cancel each other, and then you'll be left with the 6th power.
you okay with that? So if it was 2n, you get 2, right? If it was 4n, you get 4, right? 6n, you get 6. Now, we've done this a few times before. If you do not like the calculation that's in front of you, can't you find this limit first and then take it, in this case, to the power of 6? So you can switch the order. Instead of finding the limit of ugly guy to power of 6, we'll find the limit of ugly guy first, and then the answer raised to power of 6. Right, if you take this guy here, can you trust me that you get 3 and then you get 3 to the power of 6, which I'm not even going to calculate because isn't it definitely bigger than 1? Are you comfortable that that ratio has a limit of 3 and then 3 to the power of 6 is your final answer? But it, you know, it's bigger than 1. You could figure out what it is if you like. It's 789, I think. 729 maybe. But it's bigger than 1, so conclusion is it diverges. So let's do this fella. Oh, before I move on, why did this one start at 2 instead of the typical 1? Any ideas? Because I have no idea. Wouldn't that one be totally okay if it was n equals 1? Now, if I had said n minus 1, then I could have seen, okay, you can't use 1 because that's 0 in the bottom. I wonder if I just misread it. No, there's no reason in the world why that should be n plus 1. Maybe you'll get a version where it could be an issue, but evidently it's not. Okay, so this one is 8, 1 plus 1 over n squared. Right, now I'm going to do a little trick here. That 8 is going to be a pain in the butt if I keep it there. We are allowed to pull out numbers. Would you agree that this guy and that guy are going to behave the same way? Right? That 8 can be pulled outside, just to make my life easier. So I'm only going to focus on what does this do? Now, if this converges, won't 8 times it still converge? And if this diverges, won't 8 times it still diverge, right? So I'm not going to change the answer. I'm just going to make the working a little bit easier to deal with. So if you see a series and it's got an ugly number like, 842, can you just pull it out of the sigma and then just focus on what's left, make your life easier? It's allowed. So we're going to do the limit as n tends to infinity of the nth root of that guy. So it's going to be the nth root of 1 plus 1 over n to the power of n squared. Okay, if you don't like it this way, because some people don't, and you might want to see it in the equivalent form. They both are going to get me the same answer. It depends on how your brain works, whether one way looks a little bit easier to understand than the other. Okay, what would the nth root of something raised to the power of n squared be? What would it be if you took a fraction to the power of n squared and then raised it to the power of 1 over n? What would be the final simplified version of that calculation? Right, if that was 6n, wouldn't you get 6, right? But it's n squared, so what will you get?
You get n.
Again. And do we know this weird fraction? Yes. Isn't this weird fraction one of these guys? Right, 1 plus a over n raised to the power of b over n. In this particular case, a is 1 and b is also 1. So the answer to what's the limit of this as n tends to infinity is e to the 1, which is e. And e is bigger than 1, so it diverges by the nth root test. Are we good, guys? That's the end of the nth root test for the time being. there's no more questions, I'm going to move on to absolute and conditional convergence, which are the two flavors of convergence. A series sigma n from n equals 1 to infinity is absolute, can't even spell today, is absolutely convergent if the series n equals 1 to infinity of the absolute value, in other words, if you make all the terms positive, is convergent. And you might say, well, if this converges, that will bound to converge, but that's not actually the case. You could have this series here, right, might not match what this one does, right? This one here might converge and the other one might not. So let's see what could happen. A series sigma n equals 1 an is called conditionally convergent if this guy converges, but, oops, but, but when you make everybody positive, this guy diverges. Now, if a series, the original series diverges, right? So I guess I'll put this in for completeness. If the original untouched series diverges, that's it. There's no two flavors of divergent. So what we're going to look at here is a series. Typically, a question would look like that. Here is a series. Is it absolutely convergent, conditionally convergent, or does it just diverge? Right? That's the three choices that you've now got. You used to only have two choices, right? Convergent and divergent. Now you've got three. Absolutely convergent, conditionally convergent, and divergent. So let me show you an example of a conditionally convergent series. I'll pick a very simple one. That guy. Now, if I used the alternating series test, I can prove to you that this series converges. Would you agree that alternating series, you could probably prove that? In fact, we may even have done that in a previous class. You trust me? Now, if you make everybody positive, which almost always means getting rid of that guy, you now have this series. And I know that this series diverges. And I know it diverges because it's a p series, p equals 1, right? And if your p value is less than or equal to 1, you diverge. So this guy converges, and this guy diverges. That means the original one is conditionally convergent. Now you might think, why bother even having two versions of convergence? I mean, it converges. That should be all that matters to you, right? That the original one converges. I don't care if you make everybody positive. Why should that be an issue to me? Well, conditionally convergent series were discovered to have a horrible property. and a property that is not a good property in mathematics. And conditionally convergent series have the property that if you rearrange the order in which you do the calculation, the series will converge to different answers. Give you an example. 1, take away a half, plus a third, take away a quarter, plus a fifth, minus a sixth, forever. That is a conditionally convergent series. Right? Now, if you are a convergent series, shouldn't you add up to something, right? That's why you're convergent, right? You add up to a number. And this one adds up to log 2 if you're interested, right? It should add up to a number. And if you're conditionally convergent, the problem is that if you rearrange the way in which you want to do this calculation, for instance, could I break this thing into 2 series, one with all the odd fractions and take away all the even fractions? Agreed? That's me just arranging the order, right? So I'm going to find out all these guys and I'm going to take away all these guys. Now, if I do a little bit of work on that, you add up all the odd fractions for eternity, and I'm going to pull out a common factor of a half here. There is a big problem. What does that add up to? What does 1 plus a half plus a third plus a quarter add up to? Infinity, doesn't it? Divergent. So you're telling me that this guy adds up to a number, right? Something. But if I rearrange the calculation, I get this guy minus half infinity. Could you agree that that's probably not a good situation to be in? So what we have discovered in mathematics is you want an absolutely convergent series, because in those guys, you can jumble them up any which way you like, right? You can add all the even ones and take away all the odd ones, whatever you want to do, it doesn't matter. They always converge to the same number, and you never can get an infinity out of it, no matter how hard you try, right? That's kind of cool that you can do that. So that's the motivation behind absolutely convergent as opposed to conditionally convergent. Now, let's jump in and just show you an example of a question that could like that. You don't actually get much, so I'm trying to find one. Where can we go? Where can we go? Okay, here we go. Sigma n equals 1 to infinity, -6 to the n minus 1 all over the square root of n. Well, I'm going to do a little bit of tidying up on this fella. And I'm going to call it -1 to the n minus over 6 to the n minus 1 all over the square root of n. Are you okay with me separating that into 2 powers of n minus 1? So far, so good. Now, do you recognize this as an alternating series? Can you see it? Alternating series. Can you also trust me that if you take that alternating series, yeah, this one's worse. This one is easier than I made it out to be. Yeah. If you find the limit as n tends to infinity of this guy, right, I'll write that again. Isn't 6 to the n bigger than a square root? Won't that answer be infinite? So it diverges. I don't need to do that one. That one diverges. Okay, let me make one up because I find it hard to find one that is going to work. So how about -1 to the n over the square root of n, right? Let's do a simpler version of that one. Right, that is an alternating series. An is 1 over the square root of n. Can you trust me that it decreases? And I can prove it, but for speed, it decreases. Can you also trust me that the limit as n tends to infinity of this guy is very easy to calculate, it's 0. So that makes this cellar, in the good old-fashioned world, converges. Now, if you make everybody positive, you now have that guy. If I rewrite this guy as n equals 1 to infinity over 1 to the 1 over n to the power of half, do you see a p series? And the p series has a p equals a half. Okay, what do you get if p is a half, which is, in this case, less than 1, right? What can you say about a series, a p series, whose p value is less than 1, as we have here?
Diverges.
Diverges. So what we have is the original converges by the alternating series test. When you make everybody positive, it diverges. So in that world, we would say this series is conditionally convergent. Suppose I have this series. Right. Now, if you did the same kind of work that we did on this one, can you just trust me that it's an alternating series test and it converges? Right? Can you just assume I did the work and trust me, it converges? Now, if I make everybody positive, would you agree this is a p series, p equals 2, which also converges? If the original converges and when you turn everybody positive, it still converges, our conclusion is that it's absolutely convergent. Do you see the difference between a conditionally convergent series and an absolutely convergent series? Now, if you use the ratio test as your test for convergence, if the ratio test says that the series converges, you get an extra bonus. It means it's guaranteed to be absolutely convergent as well. And the reason why you get away with that is because they stuck an absolute value around it, right? In which case, you're looking at what it would look like if it was always positive. So if a series by the ratio test is convergent, it's automatically absolutely convergent. That's why all those other ones that we did on the ratio test and the nth-root test, I was saying it absolutely converges, right? The ratio test gets you that. Any other questions? Okay, then.
So
Mhm.
will we be expected to find out the difference between absolute and conditional convergence instead of just saying convergence from
In
the,
the normal test, it depends on how the question is phrased. If I give you the choice of only two things, convergent and divergent, which is basically what every other test up to today was, then you could simply just use the test and say it's convergent. But if I give you a choice of three things, then you need to kick in with, well, what kind of flavor of convergence? So I might say, is it convergent? Is it conditionally convergent, absolutely convergent, or divergent? So if you saw that phrase, then you'd need to do this thing. But if you didn't see that phrase, you just need to prove that it converges or diverges and call it good.
Okay.
Now, I want to show you, oops, almost lost time now. I want to show you the next section for today, the last section actually, brand new section. We kind of talked about it a little bit, and that is, how do we know what test to use? And this section 11.7 is called strategies for testing, or strategies for tests. So I'm going to go through these questions, and you might want to take a note of which test I suggest you should use on each situation. And I think for maybe a couple of them, we'll actually do more. We'll actually do the question from start to finish. So there are, in fact, I think the last count is there's 10 tests that you could use. 10. In no particular order: divergence test, geometric series test, alternating series test, integral test, comparison test, limit comparison test, telescoping series test. Don't think I've mentioned it. Alternating series test, ratio test, end-through test. I think I covered them all there. Right now, you should be looking, I hope, at question 1. And we're going to look at which test, or sometimes tests, would be appropriate and what to look for, so we get an idea of which test to use. If you ever get a series that's made up of only powers of n, right, like n squared plus 1 in the top and n cubed plus 2n on the bottom, right, that kind of thing, right? When you see that situation, you should be looking at a limit comparison test. So somewhere you should write down number 1, limit comparison test, LCT, and that's the test you should use on that particular one, and I believe it's divergent. What do you think you should use in question 2? And what feature is telling you that would be a good test to use?
Alternating.
Correct. That is the correct test to use here. What was the clue? What made that one stand out as an alternating series test? Well, this is what I see. Do you see that -1 to the n guy? Don't all alternating series tests have that guy, or n-1? Now, it could be a ratio test, right? Because ratio tests also have them. But in general, this one works much better as an alternating series test. So number 2, AST. Question 3 doesn't seem to look particularly familiar. You could do question 3 by 2 different tests, right? At least 2 that I can think of. There might be more I can't think of. Any suggestions for what test for a guy that looks like number 3 should be?
divergence seems easiest.
That's the easiest one, and that's the one that works. What would be the other test that would also work? Because we did that test today. It's a ratio test. Remember, 2 to the power of n over n squared, 4 to the n. E is just like a number, right? It's 2.7, but it's just a number. So if you ever see a fraction with exponents, right? 4 to the n, 2 to the n, 7 to the n, divided by, you know, n squared, n cubed, things like that. Ratio test could work. So number 3 was divergence test would be the one I would use, but alternate ratio test would also work. What about question 4?
That's the integration test.
Yes, it's an ugly integration test. If you look really carefully, if you stick an integral sign around that, isn't that a U sub question? Can you see the U sub would be that piece there? Integral test. Question 4 is, so what do you do, or when do you recognize an integral test? If the series looks like something you could integrate relatively easy, right? So does it look like it would be a U sub or an integration by parts? That would be a good choice, right? So if you gave me 2n over n squared plus 1, I could do the integral test on that, for example. N e to the minus n, I could do an integral test on that. I would just have to do integration by parts. Now, question 5 isn't really 2 questions, or 1 question, it's really 2. You're going to find the integral of this piece and this piece separate from each other. Right, let's look at this piece. Do you recognize 1 over n to the 7? What test would 1 over n to the 7 be? One of the earlier tests. Do you see a P series? Right, P equals 7, it converges. Okay, on the other hand, 1 over 7 to the n, that's a geometric series. And the R value is 1, 7, which also converges. Right, this one should be a no-brainer because, well, when you've just done something, it sticks in your head. What test for question 6? Only one test.
That's the ratio.
Yeah. If you ever see an n factorial somewhere, do you see it in this question? N factorial, right? The chances are it's a ratio test. I can't think of a situation where it wouldn't be, right? If you ever see 2 to the n over n cubed, it's a ratio test, right? Those guys kind of stick out. Ratio tests, for me anyway, are some of the easiest ones to identify. What is question 7? You know, you could have the same test again. It's okay to use the same test in 2 different situations.
Is that supposed to be a 13?
I think it's meant to be a 3 to the power k plus 1 and a 7 to the power k minus 1 all over k to the power of k. I think that's what it's meant to be.
Then I would say, could it be a ratio?
It is. It's a ratio test. And I believe it converges. Eight is a real pain in the butt. I didn't get that one, but now I know the answer. So if anybody here can tell me that answer, you deserve them. You deserve lots of brownie points because I couldn't see it. My first inclination was that it was going to be a divergence test. But actually, if you put n equals infinity into that, all you get is the tan of 0, which is 0, which means I don't know nothing. And then I was stuck because I couldn't think of anything. I know what it's not, right? It's not a ratio test, right? It's not an integral test. I went through all the things it's not, and I still couldn't find what it was. Last chance. Have a shot in the dark. What test might be used on that guy?
Limit comparison test.
Eric, you did not. I like Eric. Go for it, Eric. You just get the bonus prize. It is in fact a limit comparison test.
Really? Because that was a shot in the dark.
That was a shot, but it's a good shot in the dark. The only problem you have now is what do you compare it to? Because that's not anything obvious either, which is why I couldn't see it. That's asking too much. It's a limit comparison test to 1 over n. So do a limit comparison test to 1 over n. So that's what you should do in question 8. There is no way in the world I could tell you why that's a limit comparison test, except I now know it works, right? Some series you just keep going through the list and you try, nah, that's not working. You try this, right? Okay, shot in the dark, limit comparison test. Who am I going to pick? Now I said 1 over n. Do you know you can pick 8 over n if you like? It works as well.
So that problem we had yesterday where it was the sine of 3 pi over n.
That
that-
one was actually a disguised alternating series test. Because if you calculate that at n equals 1, n equals 2, n equals 3, n equals 4, all you get is +1, -1, +1, -1. So it was just an alternating series. They just disguised it by calling it the sine of 3 upon 2n. Here's the next guy. What's that guy? What test? To me, there's a big sore thumb sticking out, just like a big sore thumb, saying, pick me, pick me. Who is it?
Ratio.
And the only reason is that guy, agreed? Now, you just have to trust the math, right? I know it's going to be ugly, but it does work, right? You'll have to do a L'Hopital on it and you'll have to do some other stuff, but it does work. It does cancel and it does come out and it, I believe it converges. Oh, there's a sneaky one. That is not a ratio test. And it's not a geometric series test as is, but it is a limit comparison test. Now, why is it not a geometric series test? See if that 3 to the power of k was missing, it would be a geometric series test. See if that 2 to the power of k was missing, it would have been a geometric series test. But because it's got 2 guys in the bottom, it's not a geometric series test, but it is a limit comparison test. Now you need to tell me, who do you compare it to? Well, I think the top guy is pretty clear, right? There's only one guy, 10 to the k. But what will be the bottom guy? Who do you pick?
Guessing 3 to the power of k.
Right, so if you've 10 to the k, 3 to the k, isn't that 10/3 to the k? So it's going to diverge. But it's a limit comparison test to a, you could have actually done 10 to the k over 2 to the k as well, but I think the 3 to the k is a better choice. In fact, 3 to the k is realistically the only choice you should have checked. Be careful about this one. It does have a factorial in it, but it is not a ratio test. But it is a test we did today.
Nth root.
Yep. What made that an nth root and not a ratio?
Because it's raised to an nth power.
Yeah, that's it. raised to the nth power. I believe that diverges. What about 12? Oh, things to look for. If things are raised to the power of something to do with n, right? Here it's n and here it's 6 to the n. If you see that, that is an example where the nth root test would work. What about question 12? What test for question 12? Let me highlight the thing that makes the decision. What test for that one? Something ugly fraction raised to the power of n squared.
I think it's a nth root test.
It is. And you have to do some algebra on it, but eventually it works. And I think it's a converger, is it? Not it's a diverger.
Oh, but turn into that E thing. That
Yeah, it'll turn into an
uh,
E thing.
alright. Cool.
After that one, what would 13 be? Because there's a big clue in 13. And to me, the big clue is this piece here. What test could you use for that one?
I say alternating.
Do you know you could also use a divergence test on this one? So, I mean, sometimes you can have two tests. So you get a flavor of all the different tests that you could end up working with, right? So we have a little bit of time. So I know that there's what 13 questions here. Let's pick one and maybe another one after that. See what we can do. Any particular one you want to see the test and the whole process? Any particular question? I'll just start at the top and move slow.
Can we do 8?
Okay, good choice. So I'm going to switch over to the whiteboard and do that horrendously ugly one that I never saw. The good news, or at least what I consider good news, is that now that I've seen this one and I know the method for it, whenever I see anybody else that kind of looks like that, I'm going to probably use the same method. So can you imagine it might be the cotangent of 8 over n or secant of 8 over n, right? Some guys like that.
It seems like a lot of the trig ID ones are LCT.
Yeah, a lot of them are either comparison test or limit comparison test. Yeah, they are. Now, in this case, we are going to that guy there, we call AN, and we're going to compare it either to, you can do 1 over n or 8 over n. It doesn't matter, they both work. What do you want, 1 over n or 8 over n? Any choice? Do you want me to use
8 over n?
8, yeah, 8 over n or 1 over n? What do you want me to use?
1 over n.
1
Yeah.
over n gets the job. Right. Would you agree that that is a p-series? That is p equals 1 and it's greater than or equal to 1, so that makes it diverge. So if I can prove that the ratio of these two is a number, right? It doesn't need to be any particular number, except, right, don't be 0 and don't be infinity, right? That's the only issue, right? Don't be 0 and don't be infinity. As long as I can prove that it's a number, then the limit comparison test says that this guy behaves like that, so this guy diverges. So let's do it. It's going to be the limit as n tends to infinity of an over bn. That's going to be the limit as n tends to infinity of the tangent of 8 over n divided by 1 over n. And I really don't have a choice here. I have to do L'Hopital, right? It's the only guy in town for this type of question. So it's going to be the limit as n tends to infinity. If you differentiate 1 over n, can you trust me? You get negative 1 over n squared. You're comfortable with 1 over n's derivative is minus 1 over n squared. Now, if you differentiate the tan of 8 over n, you get secant squared 8 over n, followed by the derivative of the inside function, which is negative 8 over n squared. Can you trust me again that that's what you get? Right, so if you differentiate 8 over n, you get minus 8 over n squared. Now, that guy cancels that guy, but it still leaves an 8 behind, right? The negatives cancel, the n squares cancel. So I'm now looking at the limit as n tends to infinity of 8 secant squared 8 over n. And I'll brute force it. It's 8 times the secant squared of 8 over infinity, 8 times secant squared of 0. Secant of 0 is the same thing as 1 over the cosine of 0, which is 1 over 1. So the secant of 0 is 1. So secant squared is 1 squared. So it's 8 times 1, and the answer is 8. And according to the limit comparison test, if this thing is any number, doesn't need to be bigger or less than 1, just needs to be a number, then our guy behaves like this guy. So we now know that this fella diverges by the limit comparison test. That's kind of cool. Okay, we got to put the one over here. Have we got someone got a preference for one of the other ones? I'll slowly scroll through. I think we got to here. The next one looks like that. Got this one. That one. That one. There's 8.
Do a ratio test for number 9.
Okay. So let's see what that guy ends up being. I've got an itchy nose. You know that means I'm going to get angry. You're not superstitious, right? Itchy nose means you're going to get angry. Which is pretty unlikely for me. So it's 7n factorial e to the power of n squared from n equals 1 to infinity. Right. En is that guy. En plus 1 is 7n plus 1s over e to the power of n plus 1 squared. Okay, let's see what the limit as n tends to infinity of the ratio is. So it's the limit as n tends to infinity of the n plus 1 guy times the upside down guy. And forgot my factorial. There we go. Right, there are going to be a fair amount of things cancelling out here. And since everybody's positive, I'm not going to worry about the absolute value anymore. 7 cancels the 7. N plus 1 factorial cancels an n factorial, and it leaves a single n plus 1 left over. So I'm taking this slow. So I have n plus 1 e to the n squared all over this fella here. And this guy here is going to be e to the n squared plus 2n plus 1. Now you notice what I did there is I foiled this out. And the reason I foiled this out is, can't this e to the n squared cancel this guy out? And when he does, you still have some bits left over. You have an e to the 2n plus 1 left over. Are you comfortable with the cancel that I just did there? E to the n squared cancels out e to the n squared plus 2n plus 1. So basically you remove an n squared from this and that's what's left. Now this guy here, I think L'Hopital would be your friend. So it's going to be the limit as n tends to infinity of 1. If you differentiate this guy, you get e to the 2n plus 1 times a 2. If you brute force it, you essentially get 1 over infinity. Oh, that's not good. Oh, actually it is. It just means that it's slightly overkill. Right, this guy's convergent. This one is just, where is it? No, you can't do that comparison test. Although if the ratio is 0, then it doesn't mean, it just means that this, it does, it means it converges. What am I talking about?
So when you take the derivative of
It's
e to-
less than 1, it converges. Question,
take-
sorry.
if you take the derivative of e to the 2n plus 1, it's just 2e to the 2n plus 1.
It's a chain rule. Let's put x's in it. If I went and asked you, forget about the 2 because it's just a distraction. So this guy here is the inside function. So if you find its derivative, it's e to the power of 2x plus 1 times the derivative of the inside function. That's where the extra 2 came from. If I had just said to you e to the 2x, would you have been more comfortable with the 2? Right, chain rule. Not sure if you're comfortable, but that's the rule called the chain rule.
Thank you.
Okay. Well, we got to 9. Yeah, I talked myself out of it. This is the ratio test, and the ratio test, all you need to do is prove that your answer is less than 1 for convergence, which we certainly did. Right, let's return back to where we were. That's 9. There's 10, which is a limit comparison test. Here's 11, which is an nth root test. Here's 12 with a different nth root test. And there's 13, which was an alternating series test. Is there any of those last 3 that you would be interested in seeing? Is it last 4? Yeah, last 4. Got that one, that weird one, that weird one. That's pretty straightforward. Any preference? Just want me pick one for the last one? Okay, I'll pick one. Let's choose. Which one between these 2? That one's not as bad as this one. Right, let's do this one. So I'm going to try 11 and see what kind of algebra weird places we end up. Now, I know question 11 is an nth root test, and the reason I can say that with a fair degree of certainty is these powers of n that both of them contain. So I'm going to find the limit as n tends to infinity of the nth root, and since this guy is positive, I don't need to put in the absolute value. Now, when you take the nth root, you basically kill that guy there and that guy there. So we now have what's left. And what's left is n factorial over n to the 6. And in this case, can't we do relative growth rate? Which one's going to win the battle? Which one gets bigger quicker? N to the power of 6 or n to the n factorial or n to the power of 6? Which one of them is the biggest guy in town?
The factorial.
Right. And if the big guy is on top, which it is here, doesn't that make the limit infinite? And would you agree infinite is heck yes, it's bigger than 1, so it diverges. Are we comfortable with that one? Right, is there anything else you want me to do from that section? If
I just had a quick question. It's about next week of Wednesday through Friday off, but does it mean that we still have a video to watch when they post later?
what's going to happen next week, and I'll try and remember on Wednesday, and if I don't, Natalie, will you remind me, you remind everybody. Wednesday's going, Monday of next week is going to be a normal, like today. The Wednesday is going to be a video that you'll watch when you get time, right? Just like last week's Wednesday, right? So that's how next week's going to work. So one day is a normal class day like today, and the other one's just a video. I won't be broadcasting live. I'll probably make that video some other time, Wednesday, Thursday kind of thing.
Okay, and everything is still due that next Sunday?
No, that is another good point you've just brought up. Because of Thanksgiving, not this week. This week is normal, right? This week's
Right.
going to go Monday, Wednesday, homework, everything's due on Sunday, just like a natural week. But the next 2 weeks, which is the Thanksgiving week and the week after that, are combined into a single chunk of time. So that means that your tests, test 10 and homework 10, the last test and the last homework you do, won't be due for like 2 weeks. They won't be due on the week of Thanksgiving, the Sunday of Thanksgiving. They'll be due the following week.
Okay,
So, because a lot of people have got family things, and I don't think it's nice to give you a big test and a homework when you want to meet your Aunt Jo and your grandmother. Okay, so
Thank you.
that's kind of how it's going to be. Do you mind if I keep this on the video? Because anybody who's watching will
Yeah.
say, oh, okay. Right,
Absolutely.
we're good then. Thank you.
Bye.